Good afternoon, Calc 2 students. It is your instructor, Dress. I had to make a tough decision here. Well, a number of, maybe not hard decisions. First is that when I grade your quizzes, I like to give a lot of feedback regarding how, what went wrong and where and how you should have done it and whatnot. But that's hard to do electronically because I'm not physically handing you anything back. I can make some comments, typed comments, but those aren't quite as useful. So what I'm going to do is go through the quiz. Here's the quiz that you guys took. All right, quiz 1. I know it's a couple weeks late, but better late than never. And most importantly, I want to get this to you before the exam, so you have plenty of time to study. And so what I'll go through and work the solutions, and then when you see your grade, there will be very sparse written comments, and then at least you can compare it to what I was looking for. The second tough decision was this. You may hear some hammer drills, saws, hammers, pounding, loud noises. That is because I'm in my basement right now recording this in my basement office. And there's a new roof being put on as we speak, and so it's loud. My alternative was to do this at school, and then I'm talking to myself in this kind of like what I try to make an engaging tone of voice, and then that tends to annoy the people whose cubicles are next to mine. So if you don't mind the hammers and saws going in the background, you can follow along, and let's solve this quiz. All right. So the first one we're going to look at, let's take a look at this, is the integral of x secant squared x dx. All right, and that was from section 8.1. So we're suspecting that that's probably integration by parts. And I think our suspicion is right. Go up to full screen here. And let me find my stylus. We are supposed to do number 1, which is I'll just do it like this, kind of make something out of nothing there. The integral of x secant squared x dx. All right, well, as I showed you several times, the key here is to pick your u and your dv correctly. All right, so how am I going to do that? Well, we want the u to either become easier when we differentiate, or we want to pick a dv that's easy to integrate, so we can easily find the antiderivative of dv. Well, the easiest one to differentiate is x, so I'm going to pick that here, and then this becomes 1 dx. And then dv, what do I have left is secant squared x dx. And you may recall, hopefully you do, that the derivative of tangent is secant squared, so the antiderivative here is the tangent of x. All right. So I don't know if this is right, but we'll write it out and see what happens. So this integral becomes uv, which is x tan x, minus the integral of v du. So v is tangent of x, and du is dx. All right. So this, there's no calculus to be done in this part of it, but can we do this integral? Integral of tangent. What if you don't remember the integral of tangent? I happen to remember the integral of tangent, I think, but I'm not sure. So let's do it the long way and say this is x tan x minus the integral of, so tangent is the sine of x divided by the cosine of x dx. I'm like, well, what could I do here? I can maybe do a u substitution for this cosine, because I can deal with 1 over something, but not something over something. But I realize if I let u equal, and now this is a different u, so let's make this u bar equals the cosine of x, then du bar equals, and the bar just means something other than u, right? But our term, I don't want to mix u's, so u bar is just to distinguish u from u bar. So that means the derivative of cosine is negative sine dx, like that. All right, so how does that do for us? Well, we don't have a negative sign. Actually, we do have a negative sign. If I make that positive and put the negative in there. Ooh, now I'm in decent shape. Well, I'm going to rewrite this to make it look even more obvious. X tangent of x plus the integral of, well, I need a 1 over cosine, so that's a 1 over u bar, times, oh, look at this, a negative sine of x dx, so negative, or that becomes just a du, like that. Yeah, so now this integral is easy to do. That's just equals x tangent of x plus 1 over u becomes natural log of the absolute value of u bar, and then that becomes, we make our back substitution, x tan x plus the natural log of cosine of x plus c. And that is our final answer, so we put a box around that, and that is number 1. All right, a lot of stuff to remember. You know, I'm expecting you guys to remember substitution. I expect you to remember your trig identities. I expect you to remember all this stuff. If they're shaky on that, study it now. The exam is only 3 weeks or 2 weeks away. Let's take a look at number 2. What was number 2 all about? Oop. Yeah, there we go. So it's sine cubed 3x. All right, there's a little bit of work to do on this one. Nothing terribly hard, but a lot of bookkeeping. So I think I'm just going to turn the page here, and so we can work on it all. So in case we run out of room, then we've got hello stylus, hello, and there we go. Why is my stylus missing? Number 2. Oh, this is not good. Okay, let me erase this stuff. Sorry about that. I don't know what happened to the visibility of my stylus. Number 2, and it's the integral of the sine cubed of 3x. Oh, air compressor. I don't know if you guys can hear that or not, but I find it a little bit annoying. So sine cubed 3x dx. Well, the key thing with these guys is we like to have sines and cosines mixed together, because then we can do u substitutions out of that. And I only have sines here, but I'm going to split it up into the integral of sine squared of 3x times the sine of 3x dx. Now, why would I do that? Because I can use the mother of all trig identities, which is sine squared is 1 minus cosine squared of x, 3x, excuse me, times the sine of 3x dx. Now, some of you may look at this and say, that's not getting any better, it's just getting worse. It's getting worse here. What are you doing? Well, let's distribute this sine and make this the sine of 3x. Well, that's easy. In fact, I'll distribute the dx as well to make it 2 separate integrals, minus the integral of cosine squared of 3x times the sine of 3x dx. All right. Well, I'll do a u substitution here. All right, I'm going to say that the obvious choice for u is u equals 3x. And so that means du equals 3, let's see, 3, just 3 dx. All right, but we've got a little problem. I want to do this substitution. I want to put a u in there for the 3x, but then I need a 3dx. I don't have a 3dx. Well, so what I'm going to do is I'm just going to put it in there. I'm just going to throw a 3 right in there. But you can't do that. You can't change the problem. So I have to put a 1/3 out front like that. Okay. So now I've got 1/3 times the integral of the sine of u du. Because I've got a 3dx right there, 3dx, 3dx. So that's just du. So that equals, the integral of sine is, derivative of sine is cosine, so the integral of sine is negative cosine. So that's 1/3 negative cosine 3x. Okay. What about this one? Well, I can pick my u over here. I'll do a u bar. Just keep the u's separate. U bar is the cosine of 3x. And the derivative of cosine, so d u bar. The derivative of cosine is negative sine, so, but there's a 3 in there, so it's negative 3 sine of 3x. Okay. If you didn't like what I did over here, I'll do it a little different way. I've got a sine of, dx here. I have a sine 3x dx. Right, that's what I want to get rid of, because this is going to become cosine squared, or this is going to become u squared, and I want this to go away. So I'm going to solve over here, du over negative 3 equals sine 3x dx. And then we notice, I'll pick yet a different color, how about an orange, that I've got a sine of 3x dx there, and I've got a sine of 3x dx there, so I can swap those out. So this becomes, integral becomes, I've got a negative there. Well, let's write it out. Minus the integral of u bar squared, and then a du over negative 3, so du over negative 3. Now I've got negative signs all over the place, so I'm just going to pull that negative sign out, pull the 1/3 out while I'm at it, so that becomes a positive 1/3 integral u squared du, u bar squared du bar. And the integral of, so it's 1, let's see, the power, this is u squared. Now power goes up by 1, divided by the new power, so it becomes u cubed over 3. So it becomes 1/9 u cubed. Okay. So this whole thing then equals negative 1/3 cosine of 3x. Right, that came from here, that's the first part. And then I'm going to have a positive 1/9, and then u is actually cosine of 3x, so cosine cubed 3x plus c. Right. The roofing guys are listening to Van Halen right now. It's hard for me to concentrate with Panama blasting in the background. One of my favorite songs. Alright, so that gets the box there. Lastly is number 3. What was number 3 about? Secant cubed, right. Okay, secant cubed x tangent of x dx. And again, we'll start on a new page. Hello, new page. Three. I'm going to do this a couple different ways. Now my daughter just woke up, she's crying. Well, it's still better than annoying my office mates. The integral of secant cubed x tangent x dx. Now, if you're like me, you know, sine and cosine kind of makes sense. It's the y component, x component kind of stuff from trig, but secant doesn't really sit in your soul very well. Tangent, kind of. So I'm going to rewrite this. I'm going to do what I call get rid of the weird functions. So I'm going to write this as 1 over cosine cubed x times, let's see, it's sine over cosine over cosine x, and then this is dx. Simplify this a little bit. Cosine cubed and cosine, so this is sine of x over cos to the 4th, no, cos, yep, cos 4 x dx. And I'm going to write this one more time as 1 over cos to the 4th x times sine of x dx. Now, why did I do it that way? Because I can see that if I make my u substitution, this is cosine, this becomes the derivative of this, kind of. Well, let's see, how does that work? U equals cosine of x. So that means du equals derivative of cosine is negative sine x dx. All right. Well, I don't have a negative sign, so I'll put a negative sign there, and then put a negative sign out there to keep everything clean. So now I have a very nice negative integral 1 over u to the 4th du. Right, which is not a great way to look at a calculus problem. It's much better off to say this is negative u to the negative 4th du, right? Not a particularly algebraically nice way to look at negative exponents, but it makes the calculus really easy. So we have negative, let's see, exponent goes up by 1, so it goes to negative 3. U to the negative 3 divided by the new power, it's negative 3. And then those cancel, so that gives me 1/3 u to the negative 3. And what was u cosine? So it's 1/3 of 1 over cosine cubed of x. Or we could take this thing, and I'm just going to send it over this way. 1 over cosine cubed would be 1/3 times 1 over cosine is secant cubed of x, right, plus c. And that could be your final answer. Now, I certainly would have taken this, 1 over cosine cubed. I'm fine with that. 1/3 secant cubed. That's a little cleaner, but I would happily take either. All right. Now, what happens if you're a little more clever, though? And I look at this, and I write this as, well, I'm going to write this as secant squared of x times secant x tangent of x dx. Why would I do that? Because I was kind enough on the quiz to give you guys, oh look, the derivative of secant is secant tangent. The derivative of secant is secant tangent. So I hear, oh look at this, the derivative of secant is secant tangent. So if I say u equals the secant of x, du equals secant x tangent x dx, well, that's really convenient for me because I've got this thing right there. So then I can rewrite this integral as the integral of u squared du, which equals the integral of, oh, wait a minute here. Here I had a negative exponent, here I have a positive exponent. What's going to happen? So this becomes just u cubed over 3 3. Oh, well, I wound up with the same exponent, which equals 1/3 of u, which was secant cubed x plus c. So that was a heck of a lot faster if you remember your trig identities. Okay, so that's it. I'd like to briefly go over this stuff. So I put this on my normal face-to-face quizzes, and I gave it to you, I don't know, just to keep things even. But if I miss 3 quizzes because I sleep in, now you guys have all weekend to work on them, so you have to sleep way in, right? You have to sleep through the whole weekend. And then my dog dies on some other Friday morning, I can retake that quiz because my dog dying is a legitimate reason. Well, sure, your dog dying is a legitimate reason. I'm not going to make that call, right? Maybe you really liked your dog. But you've already missed 3. You know, you get 3 strokes of bad luck, and if you've already used your 3, the 4th one, I'm sorry, you do not get to retake that one. List all the file formats that are acceptable for submitting homework and take-home quizzes. There's one format, that's PDF, period. Portable document format. It's portable for a reason. Please don't send me Word documents. Don't send me huge GIFs or zip files or anything. PDFs. In the professional technical world, that's the standard. You don't submit it. You don't give people stuff other than PDFs. And then finally, there are 4 exams this semester. Which one is weighted the most? Well, it's the one that you do best on, right? If you look at my grading scale, I really try to be friendly. I give you, the most credit for the exam you did the best on, and I unweight everybody bombs an exam, right? It happens to all of us. So I'm going to weight that one the least. All right. Any questions? Let me know.